Have you ever really stopped to think about the phone in your hand? I mean, it's not just a block of glass and metal. In a way, it has its own senses. It can see, it can feel, and it can speak, just in its own language of light and electricity. So let's dive into the hidden senses of our machines, shall we?
So how do they actually pull it off? It feels like magic, but it's really just a constant conversation between our physical world and their digital one. We're going to break down exactly how they translate something like a tap on a screen or a picture of a sunset into pure data, and then how they turn that data back into something we can see and hear.
And it all boils down to two key ideas: input and output. You can think of input as how a device senses the world around it, what it sees, hears, or feels. And output is how it responds to us, what it shows on a screen or plays through a speaker. It's that simple. Let's kick things off with how they see.
Now, a computer's ability to see has evolved like you wouldn't believe. I mean, we've gone from reading a few simple lines on a cereal box to recognizing complex patterns and even faces. And it all started with a piece of tech that, well, most of us see every single day without even thinking about it.
Here's a perfect picture of that evolution. On the left, you've got the classic barcode. It's basically one-dimensional, just a simple line of data. But then look at the QR code on the right. It's two-dimensional. It uses that whole square of tiny pixels to pack in way more information. And the difference in what they can do is just massive. A barcode might hold, 20 digits, maybe a product number? A single QR code, on the other hand, can hold over 4,000 characters. That's enough for a whole website link, your contact info, or even a Wi-Fi password. It's literally the difference between storing one word and storing an entire paragraph.
So, how does a scanner actually turn a physical piece of paper into a digital file? Well, it's a really cool process of turning light into data. A scan head moves across and captures the image, sure, but the real magic happens at step 4. A sensor takes the light bouncing off the page and converts it into an electrical signal. Then, software pieces all those signals together to build the image you see on your screen.
And guess what? Digital cameras work on the exact same principle. Light comes through the lens, hits a sensor, and creates an analog electrical signal. But the crucial piece of the puzzle here is the analog to digital converter, or the ADC. You can think of it as a translator, converting that wavy, real-world electrical signal into the clean ones and zeros of a digital photo. It's literally turning light into computer speak.
Okay, so we've covered sight. Now let's move on to touch. Tapping and swiping on a screen feels so simple and intuitive, right? But behind that simple gesture, there's some seriously complex tech at work. And, as it turns out, not all touchscreens feel the world in the same way.
There are two main flavors. The screen on your smartphone is almost certainly capacitive. It actually senses the tiny electrical charge that's naturally in your finger. But older screens, like the one on an ATM, are resistive. They react to pure physical pressure. That's exactly why your phone supports fancy multi-touch gestures, but that ATM screen works just fine even if you're wearing gloves.
If we could zoom way in on a capacitive screen, we'd see a conductive layer that holds a perfectly uniform electric field. Now, the second your finger gets close, it messes with that field, and the processor in your device can instantly calculate exactly where that disruption happened. So it's not actually sensing pressure, it's sensing you. Pretty cool, huh?
All right, so we've covered how computers see and feel, how we give them information. But how do they talk back to us? How do they create the light and sound that we can actually perceive? This is where we get into the world of output.
You've probably heard of OLED screens, right? They're in a lot of high-end phones and TVs. The key word here is emitting. In an OLED display, every single little pixel is its own tiny light source. So when a pixel needs to be black, it doesn't try to block light. It just turns itself completely off. Now that's completely different from an older LCD screen. An LCD is more like a window with a big, always-on lamp shining behind it. To make a pixel look black, an LCD screen has to try and block that light, but a little bit always manages to leak through. And that's why OLEDs can give you those perfect, deep, true blacks. They just turn the individual lights off. No light, no problem. So what about sound? How does a digital music file become something we can actually hear? Well, the process starts with something called a digital to analog converter, or DAC. Remember the ADC in a camera that turned light into ones and zeros? The DAC does the exact opposite. It translates the ones and zeros from your song back into a smooth, analog electrical wave, which then gets amplified to power a speaker. But how does that electrical wave turn into sound? Well, that signal makes a coil inside the speaker vibrate a cone back and forth super fast. Those physical vibrations create pressure waves that travel through the air.
And that's what our ears perceive as sound. It's basically electricity being made physical.
Okay, now we're getting to the really advanced stuff, the unseen senses. This is where devices don't just take in information from us, but they perceive the world and react all on their own. This is where simple monitoring evolves into full-blown automated control.
This little flowchart shows the difference perfectly. A monitoring system, there on the left, it just reports a problem. Think of a simple alarm. But a control system, on the right, uses what's called a feedback loop to actually do something about it. It senses, decides, and acts.
Let me put it another way. A fire alarm is a monitoring system. It just yells at you that there's a problem. But a smart thermostat that notices the room is getting hot and automatically turns on the AC, that's a control system. See the difference? One is just a passive observer, the other is actively managing its environment.
And this is where it all comes together in the real world. Check out this automated greenhouse. It has sensors for humidity, temperature, soil pH, and light, all these different senses. The computer is constantly getting data from all of them and then taking action, like opening windows if it's too hot or adding nutrients to the water. It's a whole symphony of sensors and actuators creating a perfect environment, all by itself.
So we've gone from reading simple barcodes all the way to automatically managing entire ecosystems. Our devices are gaining more and more sophisticated ways to sense and interact with the world around us. And it really makes you wonder, right? As these senses become even more powerful and interconnected, what will they perceive next? And what will they decide to do about it?